Hey there, everybody, welcome back. We are almost done. We got 3 seconds left. Today, we're covering 8.6. And I'll spell the name before I pronounce it because I'm probably gonna pronounce it wrong. Moivre. It's spelled like the Louvre. Louvre. So I think the VRE is kind of, the RE is silent, like Louvre does, you don't hear RE. Moivre. And this is building on last section. We did R cosine theta plus I sine theta was R cis theta. Moivre adds exponents. I'd rather work out an example when we'll see how it motivates it. Let's say we had R cosine theta plus I sine theta squared. The entire thing split. Well. Algebra, the square will apply to both things, it will go to R squared and then we'll put the parentheses squared. But the parentheses squared really means multiplying them together. Twice, it's easy to forget that. It's easy to just want to square each term, but that's not how squaring works. So let's multiply that out. We've got R squared will be times whatever we got in parentheses here. I have a cosine squared theta. Plus. I have an I sine theta, cosine theta. And I actually have another one of those. I have two of those. And then I have I squared sine squared theta. Okay, what happens when we square the I?
It turns -1.
Turns into -1. So it is not an imaginary term anymore. Let's group together our imaginary terms and our real terms separately. I have a cosine squared theta here minus sine squared theta. That's the real portion. And then for the imaginary, I'm gonna factor out the I, and I have two of these. 2 sine theta, cosine theta. Everyone good with that so far? We have a formula for cosine squared theta. What is it? Cosine squared theta minus sine squared theta. What does that equal? What's our trig identity?
Cosine 2a, is it?
Or 2 theta, yeah.
Or 2 theta.
Do we have anything for what's in I? Two sine theta, cosine theta. Does that have an identity?
Yes.
I guess sine is the sine 2 theta.
Well, I hope it's not guessing, but yeah.
I kind of read the chapter, but
Well, we did that before. That was a previous chapter. That's old news. You did well on that test, David.
it's
He's like dump stat, don't need it no more, I'm not gonna take that test. Guess what? This shit keeps a building on itself. You have to fucking dump it. It's not like history,
Gotta keep it.
right? You gotta keep it. Well, isn't that interesting? We started off with the exponent on the outside. And the exponent ends up still being an exponent on R, becomes a coefficient on the angles. The math gets a lot more tedious if we upgrade this to like doing a cube or anything like that. But it does hold true in general. R times cosine theta. Use a bracket here. Plus I sine theta. And we'll square that. Equal, not square, n, we're gonna do it to the nth power for a general form. Is r to the n. Cosine n theta. Plus I sine n theta. Or r to the n cis n theta. And nicely enough. N isn't just an integer. Fractions work also. Does anyone, if we had like r to the 1/2, does anyone remember what a 1/2 means in terms of an exponent? Yes, this is square root of n, which is like putting a 2 out here and a 1 there. The general form, we have r to the m over n is the nth root of r to the m. That applies here as well. Where the n goes on the inside though, it's just treated as a fraction, not a root. So if I can rewrite it in a different format, if I said r cis theta to the 1 over n. I get r to the 1 over n cis 1 over n theta. And that applies to any loop. So it's kind of like theta plus 360. Theta plus 360 degrees times k divided by n. It just shrinks down the period. Or 2 pi right there. Like he wants to call bullshit.
Yeah, this is probably pre-algebra stuff or something.
The exponent stuff is definitely algebra.
What is like 4 raised to the 1/2? Is that, just trying to.
So along the lines of what we have here. Let's do that. 4 raised to the 1/2. Is. 2 on the outside, 4 here with the 1 there, it's the square root of 4. What is the square root of 4?
2.
It's plus or minus 2. Generally, we stick with positive ones. But the negative one is applicable.
Let's see.
Now Lewis has got the sour look on his face, he's like, fuck that ain't right. Bunch of suspicious people in here.
I remember this stuff now.
We tend to not do the plus, we tend to stick with the plus. Unless it's like x squared equals 4. I'll erase that for now. If we did x squared equals 4 and we solve for x, x is plus or minus 2 there. Because we're treating it, we're saying x squared equals 4 is what we started with. Start with x squared equals 4. And now if you look, positive 2 squared or negative 2 squared. And so does negative 2 squared. Negative 2 times negative 2 is positive 4. So let's do some examples. Actually, let's build on that one. How about negative 16 to the 1/2? Oh, this is tricky. What's going on here?
Oh.
What?
It would be 4i.
See with an I.
It's an I,
Yeah, so it'd be 4i.
right? Because this is the square root of 16, negative 16. Which is the square root of negative 1 times the square root of 16. Which is 4i. And if it's something where we needed 2 square roots, like if this was x squared. Plus 16 equals 0. Then x squared equals negative 16. And x is now going to be plus or minus 4i. Which means. Check this out, you might like this. How does x squared minus 16 equal 0 factor? We factor it.
Minus 4 and x plus 4.
It's a difference of squares, right? X minus 4, x plus 4. What do you think happens with x squared plus 16 if we factor it?
It's just x plus 4 squared.
No. We just showed the two different roots were 4i. It's x plus 4i, x minus 4i. You'll see if you multiply this out. You get x squared plus 4xi minus 4xi. Minus I squared times 16. Those cancel, right? And the I squared is -1, but we're subtracting it, negative 16. Is x squared plus 16? That's what we're doing in this section. We're gonna take shit that was previously unfactorable. We didn't have the skills, we didn't know how to. We always said in algebra, taking algebra, we said x squared plus 16 was not factorable. Because we just didn't have the trig to, it's going into the complex plane. So let's do several examples of this, let me pause and let that digest. Victor fucking to a straight mic drop with that, it's not just an A, but a high A. It's like over 95%.
Yeah, probably surprised.
I just fucking came and kicked that shit's ass. It's fucking identity shit, what are you fucking, what you guys crying about? Talk about mentoring the wrong person to be a math teacher. Fuck you, Patrick, you're old news. Victor, you wanna be a math teacher? Alright, let's give you a practice, a couple practices. Let's go with. Ooh. Now, let's keep it simple. No, fuck it, we're not keeping it simple. Square root of 2 plus I root 2 to the fifth power. And we're gonna wanna write the answer in rectangular form, like it's in. So let's work through this one together before I can. Give you another one where you try it on your own. I could do root 2 plus I root 2. Times root 2 plus I root 2. Times root 2 plus I root 2. Times, I need 5 of these, plus I root 2. And then root 2 plus I root 2. That is some fucking tedious multiplying some shit out. Fuck all that. So, better method. Convert to polar. And use de Moivre. And then convert back to rectangular. There's still some steps here, but the steps are a lot fucking quicker and easier. I'm sure one you'll fuck up the some part here, at least like you multiplied it out, there's gonna be a fucking sign mistake somewhere. So what is root 2 plus I root 2 in polar?
Got us R equals square root of.
Well, that's good, at least you weren't here, so that's excellent.
Yeah, I know, I sort of read the first page.
So R is the, remember if we have like A plus BI. R is the square root of A squared plus B squared, we're gonna apply that here. R is the square root of root 2 squared plus root 2 squared. Which is square root of 2 plus 2, which square root of 4 is 2. What's theta?
Tangent of theta equals y over x, and then you plug it in and do it in inverse tangent.
Tangent
Right.
theta is y over x, which in this case is root 2 over root 2. 1. So what is theta? What? 45 degrees or pi over 4, whichever one we want to use. So what we have here is 2 cis 45 to the fifth power. This says take the fifth power, put it on the 2. And make it a multiplier on the 45 degrees. Or if it was pi over 4 on the pi multiplied by the pi over 4.
Because it's in.
Yeah, it's the
Okay,
n here,
Okay.
that's our n. So n. So what is 5 times 45? This is where radians is actually easier. Pi over 4 times 5 is just gonna be 5 pi over 4. Which if you remember the conversions is 225. What's 2 to the fifth power? 32. Yes, it is. What, now we expand this. Cosine of 225. plus I sine 225. What is the values of those there? What is cosine of 225? I again think this is, I'm gonna rewrite this as, I'll do both. Cause some of you are gonna like this version easier. It's negative root 2 of 2, right? So we got 32 times negative root 2 over 2. Plus I, what's sign there? Same thing. And if we distribute the 32, it's gonna, we can divide by 2 because there's a 2 in the denominator both. We're gonna get negative 16 plus or minus 16 I root 2.
Square root of 2 at the beginning is 32 over 2 is negative 16. but the
I
square root-
fucking just dropped it like magic.
Oh my god, I was like, dude, holy fuck, my algebra is terrible. I was like, how did I not guess that? You gotta think, I had like some technique I didn't know. I was like, oh shit.
Yeah, I'm glad you said something. I'm like, no one says anything, everyone's gonna have the wrong fucking answer. Cause even the game operations director, Hefe is not always right. Or GOD Hefe. So the FNL, the Friday Night Labs. I showed you guys the fucking the trading card thing. They were starting to print them, I saw prints, they didn't have the back printed yet. They also got fucking iron on shit, they're gonna make one where I can iron it on. I'm gonna fucking have a fucking Lord Hefe shirt that says God on it. This is the way. Alright. Let's see, maybe I should pencil out a fucking value here first before I get all stupid. Okay, let's do this. Alright, now you guys try, we're gonna have negative 1/4 plus. Square root of 3 over 4i. And let's raise this bad boy to the. I'll be merciful, third power, lower power. And you guys work on this for a little bit, we'll talk to each other if you guys wanna work together, that's perfectly valid. I'll eat some of this fucking trader's candy that wants to talk about.
So fucking good, dude. I went on G-Run at Walmart yesterday, it was bad. I live right by it too. I got a whiteboard though, in my office. I find it's kind of easier to do homework, but I can like write everything.
I ended up getting gobstoppers too, and I was doing what Spencer did. I stuck on them for a little bit, and the next thing I knew, I was fucking crunching. Right? wonder if I made the algebra one, it's really hard. Somehow. Well. If you're comfortable working with square roots of fractions. What's the value you know? What?
Would it be 90 degrees for that?
No. This looks like shook his head, no, Baker should talk. You guys talk to each other.
Whoa, crazy.
While math is doable solo, it doesn't have to be done solo. It's actually more fun as a group activity. Why do they put whiteboards up in here? This fall, Calc 1 is being taught and fucking with the sport course. And like students are gonna be doing group work like fucking 2/3 of the time.
That'd be cool.
I just realized there's whiteboard.
They added it just like after during
Missed it,
spring
huh?
break,
Oh,
it's a recent addition. So it's kind of awesome.
I got up to here.
Question. So I know that when we give like a negative degree as an answer for like any trig function, it's usually a reference angle, like showing us like a reference angle. Because on all the homework I've been doing, it's kind of showing me that. Is that specific to the trig function? The reason I ask is because say I get like -30, am I always just gonna take like, 180 minus 30, or is that
You
depends
gotta
on the
look at it
quadrant?
to the quadrant.
Okay. Because yesterday when I was drawing my
Negative
whiteboard
30
it
is very
clicked, I was
low.
like, oh, that's why he picks either 180 or whatever the number is, it's because where it's graphed is
Yeah,
that you can see the angle. It was like a giant realization for me, I was like, this blank in my like learning, I was like.
that's
how did I
great,
always
that's
pick that?
exactly. When you make that connection on your own.
Yeah, that's why drawing it helps, like,
Yeah, oh
I
yeah,
had to
I
draw
was
it
gonna draw,
over and
I was
over.
definitely gonna draw this when we get together.
We don't do it. Is it?
Adam, Jesus Christ.
Oh my God, why are you No,
That doesn't sound like it hurt. Not very big like Abby. Fantastic.
First people in the world.
You know, it feels like it amplifies the sweetness. I don't know why. The fucking freeze drying, not me gassing up.
Purification
The look on your face, man, like yes, I fucking
Added
fart and then I
seasoning.
take a sniff while I fucking, what the fuck is wrong with you?
Well, the clarification was needed.
Was it though?
I mean, I don't know.
Really, I mean,
I was in the
just do a
deep-
little logical thinking, there's no way. Now that would be funny.
What's that?
That isn't beyond me, I have said that'll make you hungry.
Beyond
So
I
it's
couldn't
not
say it
beyond
the same,
something I would do.
said it, But, I would assume if I'm distributing here and there, right? The square root of 3, 2 is just 3, so you cancel out the square root, and then 4 squared is 16. So it's 3/16, and then when you square this, you'll get 1/16. So just distribute it to the top and bottom, and it'll do the same thing.
Maybe I know what I'm gonna get them to make as a t-shirt now that they got that shit. Background, it's done by an artist for the book series I like. Oh shit, turned out. And I'm gonna get them to print that on a fucking iron. Gonna be dope.
Thing. Oh, multiplying fractions, my brain. It's like not the part, it's just like, it's. Okay, I just. Like one thing in the algebra that I'm waiting for you to do. Right, like we did in the last one, I got 1 minus I squared 3/4.
Final answer after you cube it. You swear it.
I just didn't cube it. That would help.
So
I like did the
Let's run
cosine.
back to the fucking same version you already had. There's a Jedi master right there. Your second notebook? David. There's no way that's your first notebook.
Oh, well, I would use another shit. Found this at work and I would use it.
Nice. Yeah, you're gonna be in the semester, you don't need a whole other notebook.
Yeah, I need to work on my note taking slow. I got R equals square root 5/4. That's not the answer, but is that R equals?
Out of my head, it doesn't. Are you meaning before cubing it?
Yeah, before cubing.
No.
Yeah, that makes a lot of sense. Now, like, didn't think of the whole like in property, like bring it back out.
So this is where Patrick is taught,
Come on, dude.
because he's getting the wrong R and you're getting the wrong whatever.
Yeah, I just didn't apply the key.
Honestly, I was probably wrong. I guess go.
Class, so I'm not sure.
This is one over 16.
And now it gives you 4/16. So that's where you. That's it.
Yeah, it's just,
Oh,
you should have the same one on
Maybe
both.
that's into one.
Cause I just kept getting worse and worse.
16's right.
Okay, yeah.
16 over here.
See, it's like a
Square root of 1/4 is where that's 1/2.
Yeah, it's just makes it a lot easier.
Okay, that makes
So
so.
R here
It's 1/3.
Oh, and that's a lot easier.
So.
So 1/2 this, and did you get 120?
It is 120.
Okay,
Before cubing, it's 120.
cause I got -60, but then in quadrant 2. That was,
It is quite true, so they have to give you.
My drawings. Yes, that's why.
See, David had the right data and Patrick presumably had the right radius, together you might actually solve problems like
Look
two and
at
a half.
that, dude.
Like that.
That would. Fine, what do I do? And then we'll see. So if R is. 1/2. And then it is 20.
so 1/2 cis 1.
Times 3. You just, that's in, so you put it inside the parentheses.
That's the other part, so 122
that.
is 360, do you make it 0 or does it matter or?
Does it matter?
I don't.
You tell me,
0 like 1, yeah, cause cosine and sine. So you get,
it is periodic on 360 degrees, so it doesn't really matter which one you use. After you've done the cosine and the sine, you're gonna get the same answer.
Oh,
I want it, 0.
so it doesn't.
This is what, I apparently, if I can finally figure something out, I have to outweight you guys. Look, everybody's actually finally, like 15 fucking minutes later, finally we're gonna go. Not just you guys, Larry, like your language you're talking.
So 1/2 cube is.
You're not with your gap, buddy.
Yes, so 1/2.
Yeah, so you get 1/8 and then inside of it will be cosine 360 plus I sine 360, which is just cosine 360 0. Sine 360 is 1. So just I.
Zero plus 1.
Yeah.
That just.
Got it.
Did that, okay.
Oh.
So here's the start. Here's where I put that, right?
Mine is fine.
I did one, 8 or something, it was one.
Graph this, what's what?
Interesting.
Right.
And that's like a really good rule of thumb when the math keeps getting more and more
That's kind of awesome.
complicated, you're probably.
It makes sense. Alright.
Cause it was just, I was getting to like square root 5/4.
So
Like,
quadrant would
it's
be
like,
negative 1/4.
Yeah, we both listed everything up. So
Yeah,
both
I
you
got
guys-
this and
X is negative, y is plus.
Yeah. You got
Gonna
it.
be over here.
I don't know if I wrote it
So
right.
60 degrees match up with that.
That, yeah, I think you got it.
I did not get the highest.
So here we are, we're
Is the
done.
ion over 0 or is it
Okay, so you got the formulas ready.
It's.
That's really-
That's
the problem.
Just I from the units.
Like.
Yeah, but like if you do y
So
over
think
x,
of
you
it, even
get
the square root
But
over
negative
fraction,
root
same
three.
thing, I square the top and bottom thing, square root
like
one,
that's negative
square
root
root
three,
four
which
is
is
two,
not
so
very.
one.
Okay.
Where root one
Alright,
up
thank you.
to this quarter is a half.
Yeah, that's all.
So then you get
Lessons
r is
learned,
one
that
half.
can make you just outwit you, survivor fucking outlast.
That's given right away, that's why.
It's like coordinate, these are polar, so it's always written for like x, y, x plus y I, it's like a good way to think of it. So then
I just
as
like.
x, that's y, it would be.
Picture first.
I didn't realize you came in my work today. I don't know what I like saw you, my brain was like, I know this person, like I like to not, I was like, oh shit. Yeah, bro. John got me sleep.
Yeah, well, that's a great. Right. Trying to think what you're, where you're at, so it's.
So you put square root of 3 over 4 over -1. So this is why, that's why I'm talking. Because you're trying to find theta now, because you know R.
Yeah.
When I get something complicated like that, I start punching, I'm like, no.
Yeah, no.
Yeah, I was about to say, you'll be good. You'll get -60, right?
Yeah.
And inverse on the other
How did I
side,
get negative 60?
so,
Well, what's the right value?
yeah, and then you have to,
Figure out what quadrant you're in. You do y over x
So-
and inverse.
I'll show you this, because I was telling Joan right now, this helped me a lot. So get 10.
What's your answer?
You get this negative sign, so theta equals this, so it'd be theta equals and inverse of that stuff, right? You have to put that in the calculator.
How do you get a negative
It's that
three?
1.7, so long as.
Yeah, but it would be -60, right? So what helped me, like when you get a theta that's negative, drawing it out is what made me like, oh, it's gonna be either 180 minus this or 360
Yeah,
minus
+1,
this.
so
So
what happens if you triple that?
I was draw it,
Then it's 360.
right?
It's not even close.
So you know, x
Becomes
is
positive
-1/4, so it's about like right here. -1/4, and then you know that
So
y
it
is
was,
up here,
Yeah, this one
right?
versus.
So you know that it's
Yeah.
the last call,
Cause you had, it really helps you draw the picture and see what quadrant it's in.
right?
Yeah, 'cause if
Which is 120.
If you do inverse tangent. Yeah, negative.
But it only gives you a referencing,
Now you can build your R or whatever, like your polar.
but -60 is either in quadrant 4 or in
Yeah,
quadrant 2.
it's like when you get a negative, but it doesn't fit in the right quadrant, then you know you have to like, that's your reference and you have to take it from one.
Anytime it's negative, it's a reference angle, that's how you always know. Anytime it's a negative, it's a reference angle. Because I
Because
graphed
this
this
one's negative, and this and your y is positive.
Oh.
So you're going left.
I said the reason.
Yeah, so you know it's in the second quadrant, so it's gonna be 180 minus 60 or plus -60 if you want to think of it that way. So now that you have your theta and you have your R, it would
And
be.
then this is -1/4, this is my x and this is my y value.
I get it, so you go from 180.
-1/4 and √3/4 is over here somewhere.
This 120 and this.
So that's -60 is representing that.
And then what we just did right now was talk about.
Makes this 120.
And you can distribute that 3, so you would be 1 cubed, and then if you wanna write this out, I would get.
Yeah, I'm like, it's just, I
Yeah.
can't explain, I'm pretty sure there's something off.
1
Doesn't make a difference.
3,
How
right,
come you can't go
then
negative from
same thing, apply that cube to 1.
We could.
Right, 2 cubed is 8, so.
That's another option for -60, but that does not line up with -1/4 and
360,
That's what I was.
so 120 times 3,
here x is less than 0, y is greater than 0.
so you got that.
And that's
Now
what
you
we
just
have,
write
over here, x is greater than 0, y is less than
Then
0.
you get cosine
That's why I was-
360 plus sine
I didn't
360.
really expect it to just be a single number.
Then what's cosine 360?
Messing with my head, when it's just one number, I'm like.
What's cosine 360?
Right,
0, yeah. So 0, plus I sine 360,
I'm like saying.
so just be 1, and then 0 plus that, 1 plus I is I, so you get I.
So we got the theta up on the board. And when you do the angle, you're gonna have positive 120.
I agree, trust me.
We're gonna do cube roots on the next problem. Like, it's the next problem. Sure. Really hard now. But what's your selling out?
I see now where you got the negative root 3, yeah.
Read that now. Try that one. Alright, everyone see what we did with the tangent theta? We got y over x. If you divide this, you can multiply top and bottom by 4. And it becomes negative root 3 over 1. Which is just negative root 3, and that happens at negative 60 degrees. Now, which negative 60? Negative 60 means going back from the x-axis one way, so two of them pop up. Well, this is x plus iy, x is negative. And y is positive, so it's gotta be this one over here. And so theta is gonna be that. That's gonna be our theta. So theta is gonna be 120 that we're gonna use. Then what about r? This is where you might have some rough times. Negative 1/4 squared plus root 3 over 4 squared.
Is 1/16.
We have 1/16 plus 3/16. Right, which is
Square root of 4/16.
4/16. Which is 1/2. You can either simplify first or simplify after you take the square root. This is gonna be the square root of 1/4. Which will be square root of 1 over square root of 4. 1 over 2. If you did that here, square root of 4 over square root of 16, gets you 2 over 4. But that reduces to 1/2. So we've got r equals 1/2, theta equals 120, we've got 1/2 cis 120. Raised to the third power. So we got 1/2 cubed. And then cis 3 times 120. Without doing any calculator, this is 1 cubed over 2 cubed, which is 1/8, that's our radius. This is gonna be cosine, what's 3 times 120? 360. So we've got cosine of 360. Plus I sine of 360. And that's 1/8 plus times 1 plus I times 0, just 1/8. Boom, let's take a 10-minute break, then we'll do cube roots and other roots.
Hello.
Let's continue. I'm gonna use a new page because it takes a minute, takes to write. Let's find the 3 cube roots of -8. That's the setup. So cube root is doing this. Which means I can rewrite it as this. What exponent would I change that into? 1/3. And I'm gonna do this, I'm gonna include. 0i. Cause this is actually gonna take us into the complex plane. So what I could do, how would we go about doing this here? Same process. So r to the 1/n. Or wait. Let's do the whole thing. R cis theta to the 1/n. Is r to the 1/n, and then cis theta. 1/n times theta plus the period. Times k. Whether you use 360 or 2 pi. Or period. Just depends on which one you want. And that 1/n will apply to both. So to do this, we need to actually find out what r and theta are. Theta is actually easy if we just graph this. -8 goes over 8 to the left, and I0 being 0 means we don't go up or down. We have our vector is pointing to here in the complex plane. What does that equal? 20. We can verify that when we do y/x. But we'll see. So we're gonna apply this to the -8. Plus 0i to the 1/3. Well, let's find r. R is the square root of -8 squared plus 0 squared
What's your period, is it times?
times k. And that's the square root of 64, which is 8. So r equals 8. And if we want to do the tangent theta, we can. Which is 0. Tangent theta equals 0. When theta equals 0 or 180. Or any multiple of it. So. What we've got. R equals 8 and we're doing, we had 8 cis 180. And we're raising that to the 1/3. So this is gonna be 8 to the 1/3. And then when we do the cis theta, it's gonna be 1/3. Times 180 degrees. Plus 360k. This is the cube root of 8. The 8 to the 1/3, which is what quantity? 2. We're gonna distribute the 1/3 to each of these. It's easier if you just show it as division. In fact, this is how if you look at what the textbook shows, They say doing the theta over n plus 360 over n. I think that's a more complicated and convoluted way of showing why we're doing what we're doing. Having it factored out makes more sense and people are like, oh, I get it, okay, I'm just using the same rule as we had with. Exponents being numbered, positive, whole numbers. So I have two cosine of 2 cis. 60 degrees. Plus 120 degrees K. Which means I can have three versions. 2 cis 60. 2 cis 180. And 2 cis. 300, I'm adding 120. If I went again, I'm going to show you again, adding another 120 gets me 420. But now that's the same as that one. And I could keep doing it, another 120 is going to give us 540, but that's the same as 180. So we're really only going to have three, it's going to be these three. This three,
300.
180 plus 120. You keep adding multiples of 120 until you've made a full circle.
Oh, that.
So add multiples of k. Until you're above. 360 or 2 pi. And then you don't need the last one. The repeat. As we can see over here, this was a repeat. That's 60 plus 360. So I'm gonna write this expanded out a little bit. Cosine of 60 degrees plus I sine of 60 degrees. And this is gonna be on each of them, cosine 180. Plus I sine 180. And then. Cosine 300. Plus I sine 300. These might be easier in radians, pi over 3, pi, and 5 pi over 3. When I get above 180, I start having to think like, all right, I'm doing a lot of mental gymnastics in my head where when it's in radians. Having the denominator be a 2, 3, 4, or 6 tells me like right away where it is. Whereas I have to do some calculations when it's degrees because the numbers just get too big and I don't remember. Whatever works for you. So we're gonna have three answers here. Let's call them A, B, and C. What is A? What's cosine of 60 degrees?
Square root of 2 over 2.
It's not square root of 2 over 2.
Sorry.
So
My
confident
bad.
though. He's like ChatGPT over here. And sine is anybody but Patrick, or you wanna redeem yourself, Patrick.
Square root of 3 over 2.
He did this on his test, he fucking lost so many points on this test by fucking up angle.
Literally, yep, see?
We'll clean it up in a second. What about 180? Cosine of 180
-1.
and sine of 180.
0.
And then C. Negative I root 3 over 2, it's gonna be the negative, it's like negative 60 degrees.
See, I know some.
That's because you fucked up the first version. So, and if I wanted to clean that all up. I've got 1 plus I root 3. I've got negative 2. And I've got 1 minus I root 3. This is the only one that shows up in a calculator. You say cube root of negative 8, it gives you negative 2. It assumes you're working with real numbers. But there are complex solutions to this.
That case where your A, your C, are just sign difference.
Yes. Well, in this case, there was 3 of them. We'll do one with 4 and then 5. I'll show you. But. These usually come in conjugate pairs. Complex conjugate pairs. Which means if there is an A plus BI, there's gonna be an A minus BI. That's called the conjugate of each other.
This rings a bell, I remember this stuff from my complex numbers and stuff.
You guys wanna do an even root or an odd root? What? We're gonna do one of each, which one do you wanna do first?
Odd.
Okay. Alright. Find the 5 roots of 32.
Bless you.
Actually, gonna show something else here on this real quick to motivate why there's 3. This will help you. Having, if we said x equals the cube root of negative 8. And I cube both sides, I get x cubed equals 8. And the exponent, this is a rule in algebra, the exponent says the number of solutions. Number of answers. And so what we're doing here, we're doing x is the 5th root of 32. This correlates to x to the 5th equals 32. So we should get 5 answers. I do kind of want to retract this bit about 360. Because. You might have to take 2 lefts around, if you're like, you have an odd root and it's like to the 2/5 power. I'll do an example of that in a second. So we're gonna do it like we did last time, we're gonna set it up to look like. A complex number. What does 5 roots, what is that gonna translate, what does this translate to as an exponent? 1/5. So we're gonna do R is square root. Of 32 squared plus 0 squared. I'm not gonna be a psychopath and square that, I'm just gonna show that it's the square root of something squared. Just gives me 32. Now, if you wanna be an overachiever, if I can find this 32 squared, it's gotta be near 1,000 something. It might be 1,096. No, there's a it ends in a 4.
Yeah, you're
Hold
right
on,
there.
hold on. 1024.
Yeah.
Go back to the 2 to the 5th power and just start doing do the 2 to the 10. Alright. Theta. Verse 0 is either 0 degrees or 180, you know what, I'm gonna use down degrees too much. I'm gonna say 0 or pi radians. Which one is it here? 0. We're on the pi, if we look at it graphically, 32 is over here. So we're gonna have 0 degrees or 0 radians. So 32 cis 0 to the 1/5. Fifth, I wrote half, fifth. Will equal 32 to the 1/5. And then cis of 1/5 times 0 plus 2 pi k. Oh wait, let's just do degrees. You don't know any of the 2 pi ones, we're gonna have to use a calculator anyways. So. 32 to the 1/5 is 2. $360 divided by 5. Is gonna be 72. So we got 5 solutions, we'll check the 6th one. We've got 2 cis 0. I'm gonna actually just write out the cosine so that I'm not writing it twice. Cosine 0 plus I sine 0. We're gonna have 2 cosine of 72 degrees plus I sine of 72 degrees. We're gonna have 2 cosine. Add another 72 is 144.
What does that mean to come?
360 divided by 5.
Okay.
Plus I sine 70 or 144. Two cosine, add another 72, we get 216. Add another 72, we get 88, 288. And I'm gonna just show for illustration purposes, if we added another 120, we would be back at 360. That's not right. Did I make a mistake somewhere?
You're adding
Did I
62
listen
every
to-
time.
Is it fucking 72 degrees? I didn't add 72. I had the wrong fucking thing. There we go, 360. Oh, did fucking Patrick leave me straight again?
No, I swear.
That was on me. That should be a 0, not a theta. So this just ends up being 2, and that's the one that shows up on the calculator. The rest is plug and chug on a calculator. The exact answer is what we have. If you want an approximate answer. Cosine and my degrees a second, cosine 72, let's say we use. 2 decimal places, or, yeah, 2 decimal places. I wish I hadn't rounded there, oh well. This is approximately, we're gonna do that, and when I round here, I'm gonna round even one less. 0.6 plus 1.95. Double is 1.9. Approximately negative 1.6. Plus 1.2i. These should be the same, except the second one is negative. These are the same things off of. The same reference angle. Sine of 216. Yep. Minus 0.599. We have negative 1.6. Minus 1.2i. Guess what this last one's gonna be? Based on our conjugate pairs, even before I fucking throw this in a calculator.
0.6 minus 1.9.
Confirm it. It's 2 times 2.31. And sine of 288. Minus 0.95i, yep. So we have our conjugate pairs there. So even though the calculator spits out one answer, there's really 5. When you do complex number theory. Which is important in things like electrical engineering and stuff like that, there are real world applications to it, it's not. Pointless mathematics to make you jump through hoops. Right, like a reason why is always helpful. Now, if you're not gonna be an electrical engineer, I don't know if it's where else it shows up, but it might show up in other places. If it shows up in weird shit like that, you never know where it's gonna show up. That's the one that pops in my head right away. Alright, let's kick it up a notch. I gave you something that didn't have an I in it either time. So let's go with find the 4 roots. Negative 128 minus 128 I root 3. They wanna walk me through the steps here?
Write it out as x equals,
Do what?
write it out as x equals so we can see. I'm trying to 4th root of. Negative 1.8 minus 1.8.
Like an x plus I y kind of thing? What do you mean write it as an x?
I'm just following the pattern of the last one.
The last one was straightforward because we were able to jump straight to what we know what the radius was. Yeah. So our 4 roots is gonna say. Yeah, it's to the 1/4. I'll put it up there. It's like saying x to the 4th equals that stuff.
Yeah.
So we should have 4 answers.
R equals. That formula, right, negative 1.8 squared plus. Negative 1.8. I squared root 3 squared.
Wait, what?
Define R.
We need to find R, yeah, we're, okay. R is gonna be the square root of negative 128 squared. Plus negative 128 root 3 squared. I'm gonna actually do this, I'm gonna write this as this is ends up being. We got square root of. I'm gonna split this one up. I actually have 2 times the negative 128 squared. Don't split it like that yet. Negative 128 squared. Plus negative 128 squared times root 3 squared. Which means I end up getting squaring in 3, I end up getting 4 of those. 4 of the negative 128 squares. Which is gonna give me 2 times 128. Which is 256. Bam, I did that without a calculator. Cause this becomes, I've got 1 of these. And then I've got 3 of these. See what I did there? Yeah, if you threw it in a calculator, you're gonna get the same thing. Fine, doing shit by hand though keeps my math game up. And doing the hard ones makes the fucking easy ones even way quicker than grabbing a calculator. I have to pull that shit out, pull out my phone, find my calculator app. So R is 256. What is theta? So wait, but it breaks down into what? Tangent inverse of root 3. And where is that at? More specifically, where in quadrant 1? You're right, it's in quadrant 1. 60 degrees. So theta equals 60 degrees. I'm gonna go with. But. Is it 60 degrees? This is our reference angle. We are actually negative x and negative y puts us over here. 60 degrees is that reference angle. So it looks like we're at 240. Boom. So. We have 256. Cis 240. To the 1/5. $256 to the 1/5. And then cis of 1/5 times 240 degrees plus 360 degrees K. And we gotta keep going around until we get how many answers? We need 4 answers. 4 answers on the board. Family Feud this shit.
So your exponent's 1/5, should it be 1/4?
I don't know where I got my 1/5. Yes, thank you. From the last problem, I had the 1/5 from my head, last problem. I think the 4th root of 56 is 8. Is it? No, that's way too fucking big. 4. 16.
4 to the 4th is
4 to the 4th is 256, okay, so that part is a 4. And then we're gonna have. Cosine of 60 degrees. Plus, if I do 1/4 times 360, I get 90 degrees. Alright, now we can write out our 4 here. We've got 4 of cosine, wait, that should say cis. And then I'll switch over, it's 4 cosine 60 plus I sine 60. 4 cosine, we're gonna add 90 degrees each time, 60 plus 90 is 150. Another 90 puts us at 240. And 90 is 330. In radians, we have pi over 3. On this one. We have. No, pi, yeah, pi over 3. This is 150 is the pi over 6, 5 pi over 6, right? 240 is 4 pi over 3. And this one is 11 pi over 6. Alright. What is cosine of 60? Patrick. Redeem yourself,
What happened?
cause it's the same fucking problem, fuck this up, I can just figure it out. About 150.
negative root 2.
Not root
One
2.
more.
Square root.
So the root 2's all have a fucking 5 at the end of the angle. What is I here?
Just square root of 2 over 2.
It's 100.
Never mind, I didn't see it, sorry. Ignore me.
I just got that saying, it's fucking.
I know, 'cause you
5
said the
degrees.
5.
What does he do? He fucking immediately jumps to
It's
fucking.
good, you just gotta throw it out sometimes.
Yeah,
So see what fucking, see if he nods and gives it the yes. What about 240? We're gonna have reciprocal, we're gonna have conjugates here, which one is the conjugate of?
Negative 1/2. Is it the conjugate of the
It's
first one?
gonna be 180 plus 60, which so it's a 60-degree reference angle. Negative 1/2. Then we'll have minus I root 3 over 2. And this one must be that one. 330 is gonna be positive, we're gonna have root 3 over 2. And then minus. I times 1/2. Yes, we didn't have conjugate pairs. These are not conjugate pairs.
It's the first term, right? This is
They're close. Like if I do this, this is 2 plus 2I root 3. And this is negative 2 root 3 plus 2I. This is negative 2 minus 2I root 3. And this is 2 root 3 minus 2I. So maybe the conjugates only show up with an odd root. We had an even root here. Be interesting to see if that's always true. The odd roots had it each time, this even root doesn't. The difference between like these look like conjugates. But the conjugate only changes the sign on the I, not on the real number, so these are not conjugates. So don't automatically assume conjugates. More. We did real numbers, we did complex numbers, how about we just do a single imaginary number? Upgrade. Solve x to the sixth plus I equals 0. And graph the solutions in the complex plane. So. We're gonna subtract the I over. We're gonna get x to the sixth equals negative I or 0 minus I. And then we're gonna take the 1/6 power on each side. So x equals 0 minus I to the 1/6. R here is what? No, we don't put the I in. Not zero.
It's 1, right?
It's 0 squared plus negative 1 squared. Since there's no number on it, it's a negative, this is a negative 1I. I was wondering if that was gonna throw you guys off. So this is just 1. That's nice. I have to multiply anything through. What is, so, alright, now we need to find theta. -1/0, WTF, what? Where does that happen? Does not happen at 180.
Oh, no, wait,
Sorry.
the bottom,
Right.
the bottom, the two,
It's on the 90 degrees or 270. Which one is it?
17.
270 because we got negative I. Alright, 270. So we're gonna do 1, I'm just putting it there because we had it. Cis 270. To the 1/6. The exponent on 1. 1 to any exponent is 1. Even 0. It's the only number where the 1 to the, or the number to the 0 is still itself. So like it's still just 1, but then we've got cis 1/6 times 270 plus 360k. It's 270 divided by 6.
That, you know,
45. This is easier to do divided by 3 first, get down to 90 degrees, then divide by 2. So we're gonna have cis 45. Plus what multiple on k? 0. Distributing this to each of them, 360 divided by 6. 60. So our 6 solutions. Cosine 45 degrees plus I sine 45 degrees. We don't need to worry about a radius because it was 1. Cosine, we're gonna add 60 to it, we got 105. Plus I sine 105. C is 225. And 345. Now, you could do this without a calculator. We're not gonna do it, we're gonna do a calculator for it, but how could we find CO or cosine of 105 without a calculator? This is cosine of 45 degrees plus 60 degrees, it's actually how I set it up, right? What's the cosine formula of A plus B?
Cosine A times
Sine A, cosine.
Cosine A, cosine B, then what?
plus sine B, sine A,
So close,
sine A. Oh,
minus.
it's the inverse of cosine.
So we could work it out, but fuck that, we're gonna do it on a calculator. Like, we have to do it for the cosine and the sine, and 4 of them are ones we would have to do it on, that's. The point is, like, if you didn't have a calculator, you could do this. This one is straight out the gate, easy. Here you go, Patrick, T-ball.
Square root of 2 over 2.
Yeah, there you go, look at that, you finally got your root 2. You finally fucking got it. It's like gift wrapped for you. Well, I'm rounding it, so we're gonna say approximately negative 0.26. And sine of 105. Plus 0.97 I. .97. Plus 0.26, interesting. They swapped. That one I don't need a calculator for, what's this one? That's a dead equal, I don't need an approximation there. Yeah, we don't have conjugates. Now, the easiest way to graph this. We saw that we're going every 60 degrees. From where we started. This starting, I'm gonna make a unit circle, this is. Rather than actually doing the vector part. Cause they're all decimals, that's fucking rough. We started off with one here. The 270 degrees was our first angle. And we're basically breaking this up into 6 pieces. So that will be like, this is 30 degrees there. 30 degrees there. Which makes a 60 together. We have one going straight up. So those are the 6 graphs of those solutions. Fine. You didn't think you were gonna be taking the 6 roots of I and I today, I don't think you did, you might have. If you do, maybe you should fucking go play Vegas, do some fucking poker player shit. That's all I got for you today, we've only got 2 sections left. Shit, what's going on? Oh yeah, you know, like. Polar, graphing polar equation fucking blows. This one. Just keep adding 60 for each one.
Okay. Good test.
We have 120 on 145.
Yeah.
Yeah, this ends up being. Ends up being 45 plus 0, 45 plus 60. 45 plus 120.
Yeah, it got pretty bad there at the end.
Whatever the end is, in this case, the end is 6 here.
Yeah.
Then we would have had 45. This is 2 times 60. This is, we're gonna do 3 times 60
Are you one
here,
of the
so
proprietors of
180.
that?
Yeah.
Okay.
4 times 60 here is plus 240. Yeah,
Let's put,
if you're happy memorizing that formula.
yeah.
In my head, it's easier to just keep adding the multiples. All I did is added 60 each time. Well, once you do the first one,
What about you?
So you had 62, what, two?
Oh, nice.
I just keep
45.
going down by adding by 1 and then the 60 I got there. That's easier, I think, than doing that, but
Alright, yeah, no, I just want to understand what you.
yeah, if you didn't know what I was doing.
Okay. Alright.
This might be a stupid question, but does it matter where the eyes go? Maybe in the input?
No, but it will, usually it's better to have the I at the end, it doesn't matter because it's multiplied. But conventionally, we put the I at the end, unless there's like a radical and we put the I before the radical.
But if we put it like in the beginning on the test, you're gonna run through it.
If you put like I times 0.2, I might put like a WTF, but I'm not gonna mark you wrong. I'll make fun of you on your test, but I won't mark you.
Yeah, because the homework is, that's it. We have to.
It does what?
The homework does it different, it puts I.
Really?
Rivals.
Oh, there. That's dumb.